Okay, hi everyone. Piers, I wanted to thank you and the Constraint Project to give me a chance to share some of the thinking on Eve. The idea here is in 20 minutes to try to share some of the ideas we've developed as we've thought about Eve, in the hope of socializing those, but also in the hope that if we have some ideas which aren't so good, that people will tell us. And if we have some ideas which we don't present very clearly, that we'll also be informed about that. So it's Eve's a developing idea, and we would like to get input. I'll answer questions at the end, but there'll be something in the chat too where you can enter your comments to be considered for the broader discussion. So the basic idea behind these, Eve stands for Earth Virtualization Engines, is really that we want to bring a better quality of data to life. So we want to animate data for users, and we want to maintain the users of this data in the foreground. So that's what Eve is really about. Climate change, we've all witnessed this. It's gone from being an academic problem, which engages the knowledge industry, to becoming a practical problem, which needs to engage an information industry. So it's shifted. And what we've seen is that as the problem unfolds around us, it demands information. And the way we deliver it right now is inadequate in many respects, but there's three important ones. One is that there's large and growing inequities in information access, which we won't address through a knowledge system. The information we deliver for the actions we want to guide is of a poor quality, unacceptably poor in many cases, and it's not at the scale that people want it. And there's a fundamental decoupling between the users of the data and the creators of the data. So you see here, Eve is the users in the background, and Eve tries to do something about it. If I go to the first point about inequalities, let me just make a little bit of a diversion here. The old maps that they would have when they were just discovering the world, the parts of the map like here you'd see would be filled in great detail, Europe in the north, if you can see that up here. I don't know if you see my cursor. And then places like Africa were just sort of the sketch of people's imagination, and there'd be big gaps in the map. And in the maps, they'd say this hic sunt dracones, or, here are the dragons. The irony, of course, is that when it comes to climate information, we're doing the same thing. We're building a climate information system where we're providing unprecedented detail for those who can afford it, and the people who need it are being left in the wilderness. And if you think that's not true, then let me ask you, why is it that Cordex isn't good enough for Switzerland, but it is good enough for Namibia? If you look at all the developed countries, they have their scenarios. So I don't want to pick on Switzerland, Christoph. The United States does this with its scenarios. The UK is doing this with its scenarios. The countries that can afford it are developing a climate information system for their needs. And Cordex is what we give the rest of the world. So some of us think we need to create new institutions because there's an opportunity to bring the global North and South together to provide the best information possible globally with local granularity for everyone. So that's one motivation. Another is that most of us believe in the physics. The beauty of physics is, a physical law is something that you generalize from. And we know that at kilometer scales, we can represent things that we can't represent at hundreds of kilometers. And we saw that at this meeting. Everything from, the recent one that came to me was the grounding line. When does the lack of resolution of grounding lines for ice sheets stop mattering? And there's a paper that came out not so long ago that says when you get to about 2 kilometers, you don't need further resolution of the grounding line to reduce uncertainty. But on top of things like grounding lines and ocean eddies, landscape scale hydrology, vertical heat transport, weather and climate hazards, we know finer scales represents that. And we also know that we can simulate the climate system at these scales. And so the question is, how can we do that? If climate's the most important problem in the world, why aren't we using the biggest computers in the world to help us know how that works? And you can kind of get a picture of what it could do for you through, this is some simulations we did a while ago. People might recognize this photograph. It's the blue marble, kind of the world's most famous photograph. And it was taken in 1972, a little over 50 years ago. And it showed our Earth from the Apollo 17 astronauts as they looked back at Earth. And the beauty about this photograph is it was credited with changing the way we view our Earth. It's credited with a transformation in human consciousness. And so about 6 months ago, we said, oh, maybe we could simulate that. So we took the limited data at that time and we initialized our model, and we could run for about a week at 1 kilometer. And this is now the model. But you see, instead of just visualizing the blue marble, we can put it in motion. You know, it's probably jerky for you, but if you'll get a link to the video later and you can download it. But you show this on big screens to audiences and people catch their breath. You can see something that we're so attached to in all of its richness and its detail, but not just the clouds. You zoom in on ocean features, on eddies, on Bengula's rings, the retroflections, upwelling. You look at the interaction between sea surface temperature and clouds. You can look at how the wind speeds create fine scale features which are nearly global. So this ability now that we have at a kilometer scale, you know, we can do this. So if climate change is so important, why aren't we doing this? Because we all know what the physics can bring. So it's another point to keep in mind. I think that the third thing is realizing that ML is good at empirical inference, so ML, machine learning. And it also changes something fundamentally. And what it changes is that where once we thought information was valuable, and you have to think about this for a while, ML makes data valuable. What it does is it lowers the threshold from going from data to information. So the thing it requires or it incentivizes is to generate the best possible data and to make as much of it visible as possible, because ML gives you a way to then, in a fairly democratic way, for people to extract information. So we'll come back to that. So now I kind of like to reflect on what are we doing and how did we get here? And a lot of people always, you know, people like to say I'm trying to be provocative or things like that. I'm not. I'm just trying to get the ideas out in a way that we talk about them and don't gloss over them because we're trying to be polite. And so this is my digestion of what we've been doing as we've been trying to manipulate what was once a knowledge system into a information system. So, you know, the knowledge system I'm talking about is a research lab. And what research labs did was they made climate models, and they made climate models because they wanted to understand how the climate system works. And so what we did was we took fundamental laws and we complemented them when we had to by empiricism. So we could make calculations, let's call that climate data, that we could then test our understanding with. So we would use this mostly to create knowledge, limited experiments, testing hypotheses. Along the way, we realized that people actually want this information, and we began making our data available for people who might want information, or we began disseminating that ourselves. But the basic operation was a knowledge center, which used a model with a bit of empiricism inside to make data. And the data was sort of an external empiricism, which we then used to develop knowledge or distribute information. Machine learning comes along, and I don't know if you saw that transition, but I'll do it again. Not much changes. But what changes is that in the model with machine learning, a lot of people are trying to replace pieces because they say, well, this can make the model faster, or for some pieces like the land surface where we might not know the physics, it could make the model better. But the more we use the machine learning inside, the more the data on the outside or the empiricism on the outside is harder to trace to the laws. And so machine learning might be good at making the models a bit better, certainly faster, but they also tilted a bit more towards producing information because it's hard to go from the outer empiricism back to the laws because the inner empiricism has in some ways increased. But that might be okay if you're just interested in producing information. Anyway, it's the same picture, more or less, with a bit of a tweak. So along comes high resolution, and it doesn't change much, actually. It's another tweak. What it does when we can go to kilometer scales is it shrinks the empiricism inside, and it allows us to grow the empiricism outside. So we have a lot more information. There's much greater fidelity, but we're kind of stuck because it's not very good at distributing that information because it's so enormous. In some ways, you could argue that the centers which make the highest resolution model will be the least useful to society. And we saw in IPCC how the use of simple things like emulators were much more effective at distributing information. But the climate models, when you go to high resolution, you have more physics, might be better at producing knowledge. But again, you still have the same system of a knowledge center producing data, which then we use for knowledge or information. The problem here is what I call Borges' paradox. I'm sorry for the Spanish speakers if I mispronounce his name, the Argentinian author. And this paradox is here. I don't know how well you can read it, so I'll read it out loud, but it's an essay he wrote. It's based on some earlier work by Lewis Carroll, but I think it's nice to give Borges some credit. And he writes in this paragraph, he writes, in that empire, the art of cartography attained such perfection that the map of a single province occupied the entirety of a city, and the map of the empire, the entirety of a province. In time, those unconscionable maps no longer satisfied, and the cartographers' guilds struck a map of the empire whose size was that of the empire, and which coincided point for point with it. The following generations, who were not so fond of the study of cartography as their forebears had been, saw that the map was useless, and not without some pitilessness was it that they delivered it up to the inclemencies of the sun and winters in the deserts of the West. Still today, there are tattered ruins of that map, inhabited by animals and beggars. In all the land, there is no other relic of the disciplines of geography. So I love that because I kind of feel like Borges is making fun of me. He's saying, you idiot, you're going to make this wonderful model. You're going to work like mad to make it operate at a kilometer scale. And you're going to be, relegated to the West to rot in the sun and the wind. And he's probably right, but we'll come back to that. So where has this brought us? It's brought us with modeling centers, which are increasingly trying to interact with society to deliver information, because now we want information, not just knowledge. But the problem is it doesn't scale well. It creates asymmetric access to information, which I talked about before, inequality. And as you try to improve the basis of the information system, the modeling, the Borges' paradox means you might get even less out. So because this doesn't scale well, you get a few users at a center like in the yellow. Maybe this is under-resourced center up here in the blue, and they have one set of users, and this has no users because they're so busy with their high-resolution model. What we've done is something like this. This is the way we've scaled the problem. So we just make more centers. And by more centers, we can connect to more users, and we use more or less the same models. And a few of them might not really produce information. And this allows us to distribute more information and address more users, but it comes at a cost. And one cost is that it doesn't really scale use cases. So normally each one of these centers will address the largest communities in their vicinity. And so niche communities, which exist between all these, will be unserved because they're marginal. Another is because each center is subcritical, it makes it hard for each of these centers to keep pace, let alone advanced technology. So if you look at our modeling centers, we've ceased to be innovators in methods. So we're 20 years behind in computing. We don't develop new methodologies for data store because we can't really innovate through this method because we're replicating. We need to concentrate resources if we want to be at the forefront of innovation. It also creates structural inequalities. As I said before, less resource centers are able to provide their communities with less information. And in a funny way, as an outcome of a knowledge production or a research center, it means that either we put the users in the background or we subordinate knowledge production to information provision. Okay, one way we've tried to make this a bit better is once in a while we go through these sort of decadal efforts to compile the information from a lot of the centers and put it together. I think we're at CMIP 37 or 38 by now, and people can try to do things on top of that data. And that has advantages. It solves some problems, but it really doesn't solve the problem of scaling across use cases. It doesn't solve the problems of inequities. It doesn't solve the problems of lack of innovation. And it means that there's really no incentive for making one of these models fundamentally better. So here's where things change. And the thing that changes is how ML, machine learning, resolves Borges's paradox. Because what it allows us to do, if you think of that map, remember that map, it covered the whole territory. But what machine learning does and what the digital sphere does, it gives us a new dimension in space. We don't live in space and time. I'm in Spain where they explored new frontiers, but here, what we have is a digital frontier. We have digital space. So we unfold our map in a semi-infinite digital space, and we use AI to inquire. So the idea of machine learning isn't to replace the models, but it's to give us an ability to access the information that the models can produce that we couldn't access before. And because the barriers of going from data to information are so much lowered by ML, it opens up all of the data to many different communities to live on top and extract the information they need. So it creates a fundamentally different ecosystem where on the bottom you're focused on expanding the map, Borges's map, in ever more detail in a digital dimension. And you put machine learning on top of this empiricism to give us the first information about it, what it means. And I think anyone who's used ChatGPT will appreciate this, not for the fidelity of its interpretation of the web, but its ability to take all of that training data, just an immense amount of data, and give you a rough idea of what it says in a very efficient way. So it enables interactivity, which also encourages use of the data. So as soon as we make this transformation, it makes it conceivable that what we need to do is just fill out the training space. And if we fill out the training space, then people will develop the methods that live on top of that data to give people whatever information they want or find useful. And it puts a premium on the quality, applicability, and availability of the data, and it scales. So this is where we're at in our thinking of Eve, is that what we need to think about is, don't think about this as a replacement for a research center. Don't think about it as a new task for a weather center. Think about this as climate change is the most important problem in the world. There's an explosion of demand for information. And can we create information systems that enrich everything, that stimulate research and that's to support society? And the thinking about Eve is what we need to do is we need to make the best possible data through here kind of 5 regional engines. That's on the bottom, the engine room down here, populating the scenario space of this data layer and opening this up so that people can compute and learn and investigate and interrogate the data here. But not only, the beauty about this rather than ChatGPT is we control through the engines, the training data. And if people don't like what they learn through their little ML app that's given to you by startup X, Y, or Z, they can always go back to the data that it was trained on. And if they found out things were hallucinating and there's no data there, they can always go back to the engines and retask them to fill out things. So it creates a much more interactive information system, which gives multi-tier access to information to multiple sectorial stakeholders. It also, you can see too how doing something like this, it's not just something you do tomorrow. Building these models, it will be a tremendous effort. Advancing the technology to run them will be a tremendous effort. So it creates a renewed scientific ambition for our field. And it creates the possibility of a public infrastructure. So I have 2 slides left. Eve is really a digital infrastructure that aims to apply the latest advances in science and technology to create and disseminate climate information that is as useful as possible to many as possible. I don't see it as replacing a research or a knowledge infrastructure. I see it as stimulating a research and knowledge infrastructure. It would engage all societal sectors, especially as a North-South partnership. It would apply the most performant computing to the problem. It would bring observed and virtualized Earths together with an AI to enable interactivity and engage people in looking at how to manage their planet. In Flesh and Stone, we're really talking about a 10 billion euro effort over 7 to 10 years, spread over 3 to 5 centers. It's possible and it's necessary. And because I'm talking to a research audience, I wanted to add one slide here. And it was a little bit of what does Eve mean for us as a community. I think I talked a lot about the societal part. It gives trusted information, open, equitable access to data, better data, a platform for innovation and engaging many people. Also, a real way to involve the Global South in a partnership if we do something new, rather than as consumers of information that's produced in the Global North. But for the science, I think, many of you will see, actually, sometimes people hear this and they say, well, isn't that like CMIP, Cortex? Of course. I mean, it's not like we don't learn from the things that we do. The question is, how do we take it to the next step? So I think people who have been involved in CMIP, Cortex, Ops for MIPS, ESGF, you will see the roots of those ideas in this proposal. It gives us a whole new phenomenology as scientists to interact with and explain. Information is not knowledge. Knowledge needs another narrative, and that's what scientists provide. And so this stimulates the science. It also gives us access to computing and facilities that we wouldn't have otherwise to expand the frontiers of our field. And I think what's very important is that by it gives the knowledge provision sector the independence to criticize, explain, and create, rather than taking the knowledge centers, the universities, the research lab, and having them maintain an information infrastructure for society. It says, no, our role is to innovate, to train, to explain, to create. And Eve would do that for us. And then maybe at the end, I would just ask you, especially if you're under 40, to think about our field and where your role is and what Eve, or maybe your own idea, could mean for you and what you'll do in the future. So sorry, I went a bit long. I always do. Thanks.